When we look at lines in maths, there are three things we often need to know about. The x-intercept, the y-intercept, and the gradient. So can someone tell me what's the x-intercept? Because this isn't the first time we've seen this before. What do you reckon, Lockie?
The
horizontal line. So the x-intercept is where what? Where the line
is horizontal.
Cuts this horizontal, or is when it's horizontal, or is it when it cuts the horizontal line?
The horizontal line. Like where it goes -3 to 3, that way.
Okay, Brock, have you got a... So it's where it cuts through, if we look over here, it's where it cuts through that line. Sweet? That horizontal line. Does that make sense?
Yeah.
So where it cuts the horizontal line, I want you to write this in your books. When that graph cuts the horizontal line, what happens? Y equals, on every graph I've ever done, anytime you cut that horizontal line, what does Y equal? I want you to think about it. Just think about it first and then get that down. Lucy, what does Y equal every time you cut that horizontal line?
0.
Very good. Y equals 0. And that's really important. We know that we haven't drawn anything there, but that line represents 0 on the Y, correct? And 0 on the X. That midpoint. But everything on that line occurs when Y equals 0. Sweet? That's really important. You need to keep that in your brain for later on. Ethan, what is the Y-intercept?
What were the lines?
No, like what if you were to describe to a year 7 kid the y-intercept, looking at what you've got in front of you, what would you say?
Line going up and down.
Yeah, so when it does, what's the line going up and down?
Cross.
When it crosses. Happy with that? So when, here I'll put where, keep the language the same, where it crosses the vertical line. What's special about that point? What do we know about that point? Every graph, I've done a math for a couple of years now. Every time I look at a y-intercept, something's the same. Something to do with x. What do you reckon, Ryan? What is the x value wherever I cut that line? Y can be anything, but what about x? At the y-intercept. Cody, you reckon you could help me out? 0. So at any point like here, what's that? What's the x value there?
0.
What's the x value there?
0.
There?
0.
I could go on forever, couldn't I? Every point along that vertical line in our Cartesian plane, x equals 0. Are we good with that? Hey, I'm just going to change this up a bit. 10, 20, 30, 40. All right. Henry, you don't have to tell me how much you earn if you're not comfortable sharing that information, but give me a figure between preferably lower than $40 an hour that you would earn. 10. All right, so $10 an hour. So after 1 hour, how much have you earned? Okay, good. 2?
20.
3?
30.
Okay, very good. 1 hour ago, how much did you have less? So 1 hour ago, if you're working all day, an hour before the current time, how much did you have less? $10. So how would you represent $10 less? Minus 10? Correct? Very good. Now, I asked about that rate before. How much is Henry's income going up every hour? $10, correct? What's the gradient? If I was to draw this, remember this ruler thing that I said at the start? So let's show you why. Get rid of that 0. Should go through 0, 0. What's the gradient of that line?
Rise 10.
So what's the gradient? 10. 10, correct? So how do you calculate the gradient of a line? So what's the gradient in layman's terms? How much does Y go up? What's Y? Henry's money. How much does Henry's money go up every time he works? An hour. Does that make sense? So the gradient is saying, that's the one I want. How much does Y change How much does Y change for every increase in X? Does that make sense? The gradient of that line is 10. Every hour Henry earns, $10 more, correct? So in 7 hours, how much would he have earned? Okay, very good. New scenario. New scenario. Henry works at the same joint, right? But he's just borrowed money off Aiden. Aiden, how much money did Henry borrow off you? $5. How about we go up in tens because this makes my life easier. He owes you 10. You put some interest on it. So Henry's borrowed $10. He starts on negative 10. Cool. After 1 hour of work, how much will Henry have? $0, assuming he's a man that pays his debts. After 2 hours? 3 hours? Very good. What's the gradient of that line? 10. The gradient hasn't changed, has it? He's still earning the same amount per hour. What's changed?
Starting point.
His starting point, what do we call that? C, which is our y-intercept, because that's where it cuts the y, or the vertical line there. Well, I don't want a ruler. I'm trying to show you not to use them. Where's that blue pen going? So what's the value of this? Henry wants to earn $100. He wants to have $100. Can you tell me when it's going to happen? 11 hours later. Very good. If he was earning $7.35, could you have done that in your head? No. But linear equations could help you do it with a calculator, correct? And we're going to talk about how that's the case. So I can... Let's work through the example. Let's just... Cody's a bit of human calculator. Let's try and figure it out, because I'm not as switched on as Cody, so I need a bit more help. What's the equation of that line? Does anyone want to guess? What do we know? Y equals mx plus c. So what's the m? What's m represent? Gradient. So occasion, what's the gradient of that line again? I've got a really bad memory. Okay. The gradient of that line is 10, and we're going to talk about how we calculate gradient later. 10 x plus c. What's my c value? Someone got Riley. Riley's too good. Minus 10. Very good. Now what did I want to know? That's what y equals. So I've written down what I know. What did I want to find out? I wanted to know when Henry had $100, correct? So what axis represents $100? Is it the y or the x? Y. So I know y, don't I? What do I want y to be? $100. 100 equals 10x minus 10. What do I do now? How many things don't I know in that? 1. Correct? Can I deal with not knowing one thing? What do I do? Rearrange to get it by itself, correct? If only someone had taught me some process for rearranging that always worked. Lachlan, did someone teach you that? Because I didn't get taught that.
Move the 10 to the outside.
Which 10? There's 2 of them.
The negative.
Why do I move the minus 10, not the times 10?
So then you can deal with the 10x later.
Yeah, is there a process like a reverse BIDMAS or BIMDAS? Sweet. So I'm going to add 10 to both sides. What happens to those magical 10s on the right-hand side?
I disappear.
They disappeared. Magic. What's 100 plus 10? 110. We got some crack mathematicians in here. Fiona, what do I do now? Divide by 10? Why do I divide by 10, not subtract or... Very good. I want to undo the 10 times, so the opposite of that is to divide by 10. Cody, what was your answer before? How many hours did you have to work for? Very good. 110 divided by 10. 11, and because I'm a good math student, I'd write hours in there. Sweet. Does that make sense? A little bit? I hope. What if I wanted to know how much money he would have after 27 hours of work? What would change?
Substitute X.
I'd substitute X. And what would X be? 27, and I'd find out what my Y value is, correct? If he earned $7.35, could I do that still? Rather than 10, what would change? The gradient or the y-intercept? Does he still owe Aiden $10? Does he owe Aiden $10 still? Regardless of how much he earns, he owes Aiden $10, correct? But what would change would be my gradient. But instead of dividing by 10, I'd divide by 7.35, and that would give him my time. Sweet. Very, very good. I'm going to talk about calculating gradient now because that's probably where we need to go, and then we'll give you a bit of a chance to practice.